going to try to keep this relatively quick. We have citrate, isocitrate, and an oxidized form of isocitrate. Now, in citrate, we have our 3 carboxyl groups, as always, and then we have our central hydroxyl group. Our central hydroxyl group is attached to our central carbon, which is a tertiary carbon, making this a tertiary alcohol, or a tertiary hydroxyl. Now, we cannot oxidize tertiary alcohols because we have no hydrate to remove. So we're already at our 4 bonds to this carbon, and none of them are hydrogen. Now, since none of them are hydrogen, we can't remove a hydride, and we can't just remove one of these carboxyls to oxidize this. The reason we would need to remove something is because when we're oxidizing, we're creating a second bond with this carbon. And if we were to do that in this position, then we'd get 5 bonds to the central carbon, which isn't allowed. So to get around that, we just do a transformation. We move this hydroxyl group here. So here we have isocitrate. This is the reaction between from citrate to isocitrate, catalyzed by iconotase. And now here you can see we actually do have a hydride that can be removed for an oxidation reaction. So that's kind of exactly what happens when we go from isocitrate to alpha-ketoglutarate, except for alpha-ketoglutarate kind of is like two-stepped because this gets oxidized and then the decarboxylation happens at the same time. But to show you why this is important, this hydride, like we said, it can be removed, or this hydrogen can be removed as a hydride. So in that, we would get this. So we just oxidize that hydroxyl position into this carbonyl, and now that gives us a carboxyl group that is 2 positions away from this carbonyl, which is a beta carboxyl. So we have an alpha bond and a beta bond. We can break this beta bond. So that's why this is important to move this from that hydroxyl there so it can be oxidized and then become beta to this carboxyl. And then in the second step of the reaction to create alpha-ketoglutarate, we do exactly that. We do a beta bond break, and we remove this carboxyl as carbon dioxide.